Can you hear me now? Hello, I can't hear you yet.
Recording will start in less than 5 minutes. All right. So that should be.
Yeah, this is
Okay.
Ned. I can hear you now. Yeah.
Okay. Thanks. Yeah. Everything
Yeah.
all good now?
Yes, all
right.
good now. I will schedule it for next week for you. It's finished at 4 o'clock, right?
Yeah. Please, for every week.
Yes,
Okay.
every week. And please
Yeah.
remove you know, mute participant upon entry, otherwise we can't hear you. Okay. See you then. Bye. All good to go. Can you please?
Another thing, please. Yeah. Can you do this for my all classes, lecture as well as workshop? Can you do that for me?
Okay. Yes. Can you please let me know what time with other classes, because I will schedule this one now.
Yeah, it's a Monday 1 to 3.
Yep. Let me have a look. And you know which room?
Yeah, the same room. This 5.13.
And how about other campus?
Oh, other campus room, I don't know. Yeah, sorry. Yeah.
Okay, no worry. I will search on the
Yeah, sure. Timetabling you can see. Yeah, you can see the timetabling.
So on Monday 1 to 3, right?
Yeah, correct. That's the lecture.
Same room. Okay, no worries. Okay, and we'll use the same meeting ID. Okay.
Yeah, same. Yeah, of course. All same.
Okay,
exactly.
then. Yeah, no worries. You can please bring up your PowerPoint presentation before I leave.
Yeah, okay. You want to see? There
yes,
you go.
Yeah.
All
okay,
good?
all good. See you. Bye.
Yes, yeah. Thank you. All right. Okay. Let's start, yeah? So today, I think we cover a lot of things, and a software issue I also discussed with the dean now. So hopefully they will fix soon, right? So that's why we can continue on Wednesday over Zoom. So now, where do we go? I think we cover a lot, right? Yes. Not much, yeah. Okay, these top 4 methods. Let's do the tutorials today. Yeah, okay, let's be ready now, yeah. Let's take one example. Go slowly because that's not easy equations. And I take the hardest example here, all right? Solution is there. We'll check the answers after we do. This is the tutorial problem. You can see that, right? Solution is already provided anyway. But we need to understand the foundation is sloped. It's not horizontal, number one. Number two, the load, not only the vertical load, there is a horizontal load also. Yeah, good. Third one, oh, thanks God, at least the ground looks like level. Okay, we don't need the ground inclination factors. And this is the depth of foundations, part 3, right? And these are the slope parameters here. Of course, there are not many layers, so it's easy in that case, right? So this is coming vertical load, that's the horizontal load. Let's use our 4 methods to solve this problem. Okay, let's start from the easiest one. Terzaghi, okay? I'll open up my camp here. So I'll just switch with computer. Yeah. So then we will start. So it's a tutorial problem. What the number was that? Check that. I think 1 point something. Okay, so let's do this one problem. Then you will be very good with that. Yeah. So this is 1.6. All right. Oh, hopefully you can see what I write here. Yeah. Tutorial 1.6. We go slow, but now different methods. I don't need to sketch because the problem is there. All right. So now method 1. We'll do Terzaghi 1943. That's the easiest one. All right. So that's the start. Let's write the equation. Again, as I said before, no need to memorize. All right. Go to the equation. So I'll go back to the Terzaghi equation first. What is that? Come on. There you go. Okay. So that's the Terzaghi equation. So you can see here, right? This is the formula you need to write. Can you write it over there? So these factors, you don't need to copy these equations because there is a table to look at. So we'll directly read from the table. So copy this equation, please. I can't see from here. Maybe computer side Q ultimate or Q filler equal to CNCSC plus Q bar can be replaced by gamma D. It's overburden pressure. You can write the gamma D there directly. And the NQ plus half. Yesterday we missed one there, so don't miss today. All right. So half gamma B N gamma S gamma. That's it. So that's the formula we have. Okay. So that's you copied that. So we need some of the formula. So we will have I have a lecture note here. So I want to see what are the numbers for that particular problem, right? The problem was, how much was the phi angle of internal friction? 25 degree. All right, let's go to the Terzaghi table to look at what the factors are. All right, over there, 4.2, right? So from table 4.2, oh, I need to switch, yeah, just remind me things, yeah. From table to 4.2, we will be looking at what? NC, NQ, and N gamma, right? So the values are 25.1. Yeah, another one, NQ is 12.7, 12.7, and gamma is 9.7, right? So that's what we have the factors. Good. So let's go. That's copied. How I write is like that. Yeah, I can show you, right? So if we do that, yeah, so just refer to table 4.2. These are the factors. We got NC, NQ, and gamma. Other things we need to know. C is already known. Now we need SC and S gamma, safe correction factor. Remember, Terzaghi does not have any like a load inclinations, horizontal load, no corrections at all. Only the safe correction. That's why it is very easy. All right. Let's take those safe correction factors from the lecture note. All right. So now, just go to the original. What type of the problem? What type of foundation is that? You know, this is just the shape. I want the shape one. It's a square. So 2 by 2. Okay. So square footing, we need to copy those now. For square footing, SC equal to from SC equal to 1.3. And S gamma is 0.8, right? S gamma is 0.8. I think we know everything. Let's substitute in the equations, right? The values. Good. So go back to my maybe document camera. I'll show you now. Let's write Q ultimate equal to C. Need to read the problem if you have in your mobile phone or computer, please. Yeah, so I'm going to have a look here. So Q ultimate C equal to 25 times NC we just have 25.1. SC we just have 1.3. Done, the first part. The middle part is gamma, unit weight of soil, 17.5, that's given in the problem. Multiply, depth is 0.3, depth of foundation, that's in the problem. And then say NQ is, we just got that, 12.7. Plus half, don't miss any parameter, right? Yeah, half, 17.5 gamma. B is the width, right? B is the width of the foundation, which is 2. And the N gamma is 9.7. SC is 0.8. S gamma, we just calculated. Okay, that's your job now to compute, please. Yeah, use calculator, right? Yeah.
So the base of the foundation in the other side, there is a
Column.
more than durability. So we know should average.
No, this is the same. Just the drawing is not that good. But yeah, of course, only the thickness below is. We consider the minimum one. Minimum gives you the critical. Okay, so if your foundation is not in the same level below, so it's better to take the minimum that gives us the more safety. All right. Okay. Good. Okay. So what's the ultimate? Now use calculator. It's not that bad. It looks, my writing also, we can see well. All right. Press your calculator, please. Thousand 18.25 kilonewton per meter square. Kilopascal you can write, yeah. So kPa. It's all right, yeah. All of us, we are all right. Is there any in the problems? Can you go and have a look problem whether it's the ultimate they want or any safety factor or anything? Are the dimensions accurate for the loads if you use the safety factor of 3? What's the allowable now? Can we do that allowable now? Q allowable equal Q ultimate maximum load divided by factor of safety, right? Which is 3 equal to 1018. Yeah, so that is 1018.225 divided by 3. Oh, more or less around 350, yeah? Okay. How much?
339.405.
Okay, 339.405. Of course, we don't need to go that detail in the design, right? Yeah, we can approximate values, but for tutorial problems, whatever comes in the calculator, you can put that in. Is all good? Yeah? How easy this is. There are a few other tutorial problems that requires use of Terzaghi theory. I'm sure you can use it now. All only we need is safe correction factor. Nothing else. Even the load is inclined or the slab is inclined or ground is inclined. Don't worry about anything in Terzaghi theory. It didn't give those type of things. But other advanced theories, they gave us a lot of corrections that we will be doing next. Good, yeah? So there are a few problems in tutorial using Terzaghi theory. Please try yourself, okay? I'm not going to do those all. But I'll release the solution anyway, so it should be, you can check later. What is the second method we learn? I think Meroff? Okay, let's go to the Meroff now. I'm very bad at memorizing, so I need to look at this. Oh, that's the Meroff's theory, second theory, right? You understand the theory first, right? There is an equation. It's a vertical load that, inclined load that, all right? But over there, load is vertical to the foundation, so it is okay, right? So, but we need to calculate that. There is a horizontal load also. Yeah. That's why there will be the resultant force somewhere in the angle. So that's why that gives you the inclined load. So we need to use the second equation. You understand what I'm saying? Yeah. Because one load was vertical to the foundation, but there was a horizontal load. Yeah. overall load will be inclined. You know the resultant, how to calculate any structural engineering, right? That gives us that. So we need to use this equation. Correction factors we need. Shape, depth, and the load inclination. How much was that? Forget about base inclination, no ground inclination factors here. Only additional thing you need to do is load inclination factor, depth factor. Yes, he was there in previous Tejagi also, right? Shape correction factor was there. Is good? Yeah. So you know what to use. Now, what to use? Don't memorize again. Shape correction factors in these equations. Depth, this one. Load inclination, these equations. Good. Let's start from the first bearing capacity factors, NC, NQ, because they are different, because guys are different, they use different values, all right? Here you go. It's good. Now, next. Document camera, go there, and the one page is done. But for your like a test or exam situations, we will not ask all methods, right? You specify one method just with that. Because we are learning one of the most complex problems, sloping with loads. So we are trying to use all methods for that problem. Is good? Yeah. Let's do the mirror off. So method 2. Which way I twist, I don't know, but yeah, there you go. Method 2. We call it Rob's equation. Okay, let's copy the formula, the formula first. Okay, go to the computer. Okay, so just copy that. Second one is better. Of course, everything is same. Only difference is just the correction factors, right? The correction factors there. Can you do that for me? Hopefully, I will not miss those things. So, CNC Q ultimate equal to CNC SCDCIC plus gamma D. I'll write directly gamma D instead of that Q. All right. So NQ again, right? SQ DQIQ, SQ DQIQ, and then half gamma. So N gamma S gamma. Oh, N gamma S gamma. D gamma I gamma, right? D gamma I gamma. Look at this. All right. Let's talk about the factors first, right? Okay. The factors not here, right? There should be a table somewhere. Go to the next. Again, remember phi is 25 degrees. All right. So if you go to the next, oh, that's all total together. Oh, here you go. Okay, bearing capacity factors, Meyerhof, Hansen, and Bisik, all are given in one. If you see in the table, you see NC and the NQ are same with other methods too, Hansen and Bisik. Only N gamma is different for H is Hansen, M is Meyerhof, and B is Bisik. Okay, so we need to check. Now we are doing Meyerhof equation, so that's why we will be using these factors. Can you copy the factors for 25 degrees now? So it must be from table, what number is table? 4.4? From table 4.4. So NC must be equal to 20.71. NQ must be equal to 10.7. Yeah, N gamma equal to, that's a Meyerhof. We need to check the Meyerhof one. No, second one. All right, first is Hansen. Yeah, so we got to be careful. 6.8, right? 6.8. Good. I think we got those factors now. So now go for the corrections. Good. So now we need first corrections. Let's start from shape corrections, right? Yeah. First shape, and then let's do and then depth, and then we do the load inclination, right? Yeah. So now shape correction. I am on the document camera or no? Shape corrections? Shape correction factors. that what? SC, SQ, S gamma. We need 3 shape correction factors. Right? Again, what do I look at? Lecture note. Yeah, this is the Meroff, right? Okay, this is shape, depth, and inclination. How nicely it is presented here. This is shape correction factors, depth, and inclination. For the shape, what we need this Kp value, right? B by L is the size of the foundation, which is 2 by 2, so it becomes 1. Okay? Only thing we need is Kp. Value of Kp is given here. Can you complete now, please? What is Kp there? First, we need to get the Kp value, all right? So Kp equation is 10 is square, 45 plus 5 over 2. 10 is square, Kp equal to 10 is square, 45 plus 5 as what, 25 degree? Yeah, 25 over 2. Can you calculate how much you got the Kp one now? Yeah, oh, I don't know whether it is outside of, it's good, yeah? You can see I want to compute Kp first and the 10. So just use your calculator. Scientific calculator is enough, right? Just 10 value. It is in degree, okay? How much you got? $45 plus 25 is at 12. 12 point is 45, 57.5. 10, 57 should be 2 point something, yeah? 1.96. Yeah, 1.96, yeah? Smaller than? Would be equal to 10 squared 5. Can I check the formula one more time? Is there anything others there? Nothing, right? Yeah? Kp equal to, there is a table also that gives the value Kp, I think. The same table? Oh, no. 210 squared is a different one. It's not gain. Which one is giving Kp? I think Terzaghi one. Table? Is that Kp given? No. All right. How much you got? We got something different than what we have here. So 10 square, 45 plus, can I just use calculator here and do, if I can. Calculator, you can see there, right? Yeah, so let's try. So this is scientific we need. How to convert into scientific? There? Yeah, there you go, that one. And can I pull this out? And then there is a trigonometry function. I think 10. And then first I think I need to do this one, right? 45 plus 12.5, yeah? 12.5 equal to that. And there's a 10 value of that. 10 of that. 1.569 and square of that, right? Kp is square, isn't it, right? So square, where is square? There you go. 2.464. Okay, 2.464. That's what I thought. The square of that should be around, yeah. You got it, right? You saw how I calculated, so. So in that case, and can I go to the, and then what we need, other things. For square root of that also we need, if you want to compute and put that. I think that's it, right? Anything else we need? dB we already know, depth already all done, except this, okay? So we'll do that next. All right, so we got that. Let's calculate SC. Can we write the SC equation? 1 plus 0.2, 1 plus 0.2 Kp, and then B by L, right? Yeah, B by L. Sorry, I need to remove this first. Yes, and then I'll do again later on, right? So equal to 1 plus 0.2 Kp, we calculated 2.464. B by L is 1 over 1. Sorry, 2 over 2, which is 1. All right, so can you compute that for me, SC? How much you got? 1.493? All right, okay, that SC we got. Let's go back to the another equation, which is SQ. SQ equation is second one. Oh, equal to S gamma, yeah? Yeah, more than, yeah, that's all right. S gamma also, I can write that same values, right? Yeah. SQ equal to S gamma, so 1 plus 0.1 Kp B by L. Oh, just 2 there, and there's 1 here. That's it. So Kp B by L, right, which is 1 anyway, 2 by 2, equal to 1 plus 0.1 Kp is 2.464 times 1. Can you do that calculation for me? $1.25? That's it? Yes. Oh, okay, good. So that's done, shape factor done. What's the next? Next is we will go for, what correction is that? Depth correction. Can you write now depth correction factor? Factors again, DC first, and then DC. Just start with DC first, all right? Okay. What's the equation for DC? 1 plus 0.2 square root of Kp. 1 plus 0.2 square root of Kp. I wonder how they come up with this type of equations, right? Yeah. So D by V. So depth is related with that, right? So equal to 1 plus 0.2 times square root is what? 2.464. All right. Times depth is 0.3. That's the minimum depth we discussed before. So it's a 2. Can you compute DC for me?
We can use the Kp of the one.
Yeah. Same thing, but square root there. That's it. The same value, but you need to do the square root of that number. You can see my calculation also. Yeah, it's outside of page. Or maybe I'll pull this little bit up so that whole page can be shown at once. Yeah, good. All right.
SQ is 1.25, not 2.25.
Q or DC we are doing?
No, sir. Everyone.
Two.
SQ is 1.25.
Oh, 1 point. All right, thanks. Oh, 2 point would be very big correction. Yeah, multiplying by 2. Yeah, you're right. Yeah. Thank you. Yeah. I'm not pressing calculator. I'm depending on you guys. All right. Okay. So go for the second calculation now. DC. How much you got?
So SQ, SC, and S gamma values are same.
No. SC is I think 1.493. We calculated before, and SQ and S gamma are same. Based on the, of course, not from memory. Yeah, here you go. Where is my computer? Not coming? What happened to my computer now? Yeah, it's coming. Yeah, there you go. See, that's the same there. Where I'm looking at. This one, right? Did you see it there? And did you see the equation here? Yes, C is that, and both are same with that equation. It's up to, of course, we need to follow strictly the process. I'm sure you had done before, like Terzaghi, right? Yeah, very easy one. But these extensions, right? We need to.
We have done this also, sir.
Is it good? That's good then. Yeah. There are maybe basic and depending upon the university, right? Some university that is only some that do more. It's good. How much you got? TC? How much?
1.047.
047, 1.047. All right, here we go. So other one, two things. I think they are same again.
Yeah.
They're also same, right? Yeah, second term and third term. Can you write that and then can you do that? This is only 50 case. Both would be 1, right? But 5 is more than 10, so we can use that. If you ask me what happens 0 to 10, they don't provide information. But for me, 0 to 10 is usually considered 0. It's a cohesive swell, right? Very small friction angle, right? It's very close to, so it is safe to compute using that. That's why they didn't provide that. Okay. So let's do this one. So what is the formula? dq d gamma. dq equal to d gamma equal to 1 plus 0.1 root kp, 1 plus 0.1 root kp d divided by b. Oh, that's just the 0.1 difference. That's it. So 2.464 times 0.3 over 2. It should be a little bit smaller than before because multiply by 0.1 is smaller than 0.2. One point 0.023. Oh, that's just a little bit down. So depth correction factors we done. Now what is the other correction factors? Of equation they want? Just the inclination. Now you need to find the resultant. Okay. So what angle will be the resultant? You need to find this angle. Do that. So horizontal is coming what? 200. How much is the load? Can you check? 200 load horizontally coming. Yeah, vertical is 600. Yeah.
Yeah.
Okay. So let's do that, right? So if horizontal coming 200, and then vertically it is coming, how much is 600? What will be the angle this now? Theta. So it will be what? You can see, right, my writing, yeah? So it's a 10 theta must be equal to 200 by 600. Theta must be 10 inverse 200 divided by 600. Yeah, you can directly calculate the angle making by the two forces, right? Resultant force. How much is that? 10 inverse 1/3, maybe around 10 degree, or maybe a little bit more, I don't know. Maybe up to 20, it may go 10 to 20 around, just guess. You compute using calculator, come on. 18, yeah, that makes sense, right? 18.4 degree, because it should be small angle because horizontal force is smaller compared with the other force, so angle must be smaller. All right, so now go back to our formula sheet provided, and then compute. IC, IQ, same now. Yeah, this is IC, IQ, same, just theta 18 point, whatever we calculate, divided by that. What happens if theta is 0? What theta 0 means? Load is vertical. Yeah, totally vertical, right? In that case, correction factor should be 1, not 0, not 0. Multiplying by 0 is everything 0, all right? So 1. That gives a very clear message here, right? If the incline, so there are some correction factors, it reduces the bearing capacity. Otherwise, it will be 1. All right, so can you put that value there and compute this? Yeah. That one, not theta 0, we can consider this one with this. All right, IC, IQ. I need to go to the next page. Okay, so inclination, load inclination factors. All right, so IC should be equal to IQ, right? Yeah, IQ equal to, the formula is, oh, that's very easy, right? 1 minus theta, yeah. 1 minus theta divided by 90, is it square? Yeah, or there we go, yeah, square. So equal to 1 minus 18.4, you said to me, yeah? So 90 squared, because both degree, they cancel out, value becomes radian. So another is I gamma. I gamma value is given for 1 minus 5 degree here, right? Yeah. So 1 minus theta over 5. Over 5, not a square, nothing, yeah? Oh, there is a square. There is a square. Here we go. Equal to 1 minus 18.4, phi is 25, yeah? Angle of friction for our soil. I think that should do the job. So 18.4. So I want to go to the document camera and then let's compute these two. How much you got first one? How much you got? 0.632. All right. Okay, good. And then second one you got? 0.067, yeah? All right. Oh, very close to 7, yeah, 0.7. That's good. Done. All factors done. Now put back in our original equation, please. Can you do that for me? I'll open these original equations here on the computer and then so that we know, right? Q ultimate equal to now, we need to do for the inclined loading. So second one, right? Q ultimate equal to, I'll not copy the equation now. C, how much is C we have? Check in your problem. 25, good. 25 multiplied by, and the NC, what factors we just got before? NC is 20.71. Yeah, good. 20.71. And then NC, SC, shape correction factor. SC is 1.493. Times 1.493. And then there was what? Yes, D depth correction factor. DC, which is 1.047. 1.047. And then the other one is inclination factor. The first one, 0.632.
Note.
You want to see notes? I want to see my formula. Otherwise, I can't remember that. All right. I just
You can share your notes, right?
No, I don't think that they allow because of the Zoom connection. It is pointing to the students who are connecting from Zoom. Okay. Otherwise, we could do that because it's already Zoom recorded. So, if somebody joins from the Zoom, that will display there. Okay.
No one?
No one now. Somebody said yesterday joining my Zoom, and I connected today, but no one there. Maybe timing? Don't know. Currently, no one in Zoom. All right, that there it says 1D. You are the 1D person in the Zoom, right? If somebody there, we can see the face, we can talk with them, we can do. I think some visa issue. I think there is a delay in Australian visa, and some students is still coming. Maybe by next week or so they will arrive. This is the first part. Still, there are two other parts, guys. This is not final, all right? Plus. I want to go to my formula, all right? Okay? Okay, that would be easier, right? So gamma D. Gamma is, how much is gamma for our case? 17.5, all right? Okay, 17.5. Depth is minimum depth, which is 0.3. And then NQ, what we got just before NQ? NQ is 10.7, you're right, yeah, 10.7. And then what else we need? Next, NQ is SQ. We just got that before. SQ, right, 1.25?
Yeah.
Correct, yeah, 1.25. And then SQ done, so next is DQ. DQ we got is 1.023. 1.023, you check here what we calculated before, right? Yeah, and multiply by, and then we need IC. Oh, second one, not IC, IQ, right? So IQ is the first one, yeah, 0.632. 632, that's the second term. And then the third term I write, and also you might note, yeah? Plus half, gamma is what, 17.5? 17.5, and a B. B dash is B because there is no other things there, no effective, no eccentricity, it's the center load. So that means B is 2 times. And then, oh, I think the B is missing at the bottom, yeah? I think the formula, there should be a B there. Half gamma, not only the correction factors, there should be B, right? Can you write in your somewhere note? Yeah. I think there is a B missing here. That B, same thing. That's the same, yeah, gamma B, right? We knew that. Oh, come on, you guys are typo in the book. There should be B there. Yeah, similar to this, right? Only I factor is more. Similar to us, but I factor is more, that's it. Okay, gamma B, say half 17.25, that's it. And then N, what we need? N gamma we have before 1.25, no, 6.8, correct? 6.8 times, and then N gamma, after N gamma, there is a S gamma. S gamma is 1.25, yeah, times, and then what we need? N gamma, S gamma done, D gamma 1.023, 1.023 times, and then we have last one, I gamma is 0.069. There you go. So now you can see my note that the three terms, right? I provided a little bit of spaces between. If we miss something, we can check back. So this is the first term, that's the second term, and that's the third term. So don't forget there is a B there, right? Half gamma B there.
So how we gonna calculate this Q bar in the second one?
That's the gamma D. Q bar is like a overburden pressure. It is 0.3 depth. So there is a unit weight of swell multiplied by the depth. Okay, pi is always gamma D.
Gamma D.
All right, yeah. So gamma D is the Q bar. Thank you. Yeah. Okay, now your job to compute. It's compute separately, and then we can check each individual. What do you get the first term? Or you can do all total together. And
501.31 first term.
total, first term?
First term.
How much you got?
510.
510, that looks quite big. 25 times 20.7 times 1.493 times 1.047 times 0.632. Do it one more time. Maybe I'll also do here, yeah?
Yeah, it's
Same?
yeah.
Okay, then that should be all right. Maybe they calculated something wrong here. Okay, we need to check, right? Yeah, please check like that, because sometimes 25 times 20.71 times 1.493. Oh, they made a mistake in calculating that. Yeah, I got it now. I think you are right. 1.493 1.047 times 0.632. You are right. There you go. So 511.49.
Yes.
Okay, 50. 511.50, the first one. 511.50, the first one. Second one.
45.27.
49.27.
45.27. Yeah.
Okay, good. And third one.
10.5. Yes.
10. Look at this. 5, 8 or something. Just 10.5? 5.2. All right, look at this. The contribution, right? Can you see the contribution of the bearing capacity? No, I don't have there. All right, contribution from the bearing capacity. Look at the first contributed a lot. Yeah, second very small and third. Look at this. Sometimes you can neglect this. This is small, right, for the design. So this is the major one. Can you sum them total together and then also the use the 566 total?
Yeah, 566 from 567.
So 566. Oh, that total is all good now. Then I think there is something wrong in the middle, right? 566. Okay, I'll write just 566. And if you divide by 3, what you got?
2.3.
Oh, even not 200, 180 around?
Yeah, 88, sir.
Kilonewton per meter square. Look at this. How much we got from Terzaghi? 350.
Yeah.
Now we get 180. So what they generally say is, if the load is inclined, Meyerhof equation is in the conservative, it's very safe side. Okay, so Meyerhof usually gives the smallest value. Okay, so that's the generally comment. You can read in the solution comment also that is written there. Meyerhof is too conservative. Maybe it is too expensive to have a foundation like that. Yeah, but of course it's safe. But how much safe, right? So we need to spend money to make things safe. Yeah. So how much money you want to spend to make things safe? Okay, that depends on engineers, right? We decide. Okay, so 2 methods, I think there is no issue at all, right?
Yeah.
Other 2 methods are really tricky. A lot of corrections there. So let's do, maybe we may not be able to do both. Let's do one. And then you see the solution, and then if you have any issue, you can talk with me.
Yes.
It's good?
Yeah.
Let's do the not the Hansen one. Hansen is little, there are some informations there. Let's do the basic one. Okay? Okay, so go to the Hansen has little few corrections because I have written here the comment. Can I show you just before? Because for Hansen, you see now, even though they give the table corrections thing, for Hansen, I think we used to calculate safe correction factor. We also use the inclination factor. So you need to calculate inclination factor first to calculate safe factor. Only for Hansen, okay? That's the main difference, otherwise it's the same. All right, let's do the basic first.
The calculation for inclination factor is used by the same formula?
No, there is a difference. That's why you need to look at the formula. Don't generalize and guess it. Look at this. This is which one? Okay, just wait first. So this is basic, right? Yeah? NQ, NC, and gamma, right? This is the equation for Hansen. So same equation is used for basic. Okay, you can see that there. Look at this Hansen. This all, what is different? Only GC and the BC are different, right? Otherwise, SC, BC, with all other factors, IC are same. But be careful, these are not the exact formula with what we use Meyerhof. They have different formula for these also. Okay, so that's why you need to see the table. Did you see that? Table 4.5 for safe, depth, and other factors. You see, they have written there. It's not the same formula, but yeah, the overall formula is same, but looking at the different corrections are different. Let's do this one first, yeah? Basic, I want to go to my document camera first. Okay, method third. So basic. This is the newest one, I think 75, I believe, yeah.
75 is also.
No, 75 is My age, guys. Yeah, come on. It's not that old. Yeah, it's okay. For swell mechanics, we are looking at 1840, 1943 things. Yeah. Swell mechanics is still not developed, right? It's still we are. Otherwise, think about this. Why we use factor of safety 3?
Yeah.
What is the meaning of that? Come on. In structural engineering, you use what? 1.25, 1.5. Yeah, we know a lot of things there, but well, look at this. We know it. Yeah, so that's
So complex.
we need to live with it. Okay, so it's complex. Swell is okay. We assume some swell parameters, right? The phi and a c. Just over here is different than just over there.
Yeah.
And then you put the foundation all over it, and you assume one homogeneous swell. Come on, that is not correct. That's the reason why we use those factor of safeties. Use factor of safeties. Sometimes we use 4, 5, particularly in slope stability analysis. Okay, it's not that easy thing. Okay, let's keep going. So basic equation, right? Yeah, and then I want to go to the computer first. And let's see, this is Hansen. I think same bearing capacity equation is used by Visick. Should be written here somewhere. Yeah, Hansen's Visick is same as Hansen. Equation is same as Hansen. The correction factors are different, so we need to look at the different tables. Can we do that? Can you just copy that formula first, Q ultimate, in general? That one. Q ultimate, just this formula, right? Not 5-0, that's why we can't use this. We need to use that one. Oh my God, yeah, that's a very long one. Yeah, you guys are young and you can do this type of things, yeah?
You don't need to get memorized.
No.
If you are in Nepal or in India,
No way to memorize this at all, yeah? I used to have like a closed book exam for this, but provide these all formulas. And I decided, okay, formula is like a 25 pages. Yeah. So instead of doing that, make it open book and the students can use it. DCIC, okay. DCIC, ground inclination GC, and the base inclination BC. In this case, right, you already know our slab ground is horizontal. Yeah. That's why G factors, GC, GQ, and the G gamma will be 1. Okay, but B, because base is inclined, so we need to compute those factors. All others we need to compute anyway.
If ground is inclined, then we will have to compute
G also, right? So all of this. So ground is still horizontal there, so we don't need to. But if ground is inclined, we need to calculate G factors. There are equations for that too. Okay. So let's do the first. Yeah, okay. I'm not going to copy. I'm too lazy copying this. Now let's start calculating, right? So first NC, NQ, and N gamma. All right. Let's check the table. Lecture note is there. So this is calculated. There is a table for that. So we can directly go. You can use the equations, but table is better. That's the same table. Which method are we doing now? Is it? Which one? All others are same?
Yeah.
This is the one we need to check, yeah? So 25, so 20.71, 10.7, but other one is? Is it 10.9? Yeah. The third one is not 6.8, but 10.9. Can you copy that now? So NC would be 20.71. Is that 20.71? Yeah, good. NQ would be 10.7. Yeah. And then N gamma for basic would be 10.9. Yeah. 10.9. Good. Done. That's factors done. Let's start with the shape factors now. Okay. I'll write just SC. Okay, shape. But now we need to look at the different tables, all right? Okay, so can we go to the next one? So did you see that? What's the first one? Visick and Hansen, okay? Shape and the depth factor. You can read at the top. So this is the one we need to be using, right? H is Hansen and the B is Visick. Okay, they put together in one table. So for the shape factors, because phi is not 0, All right? So we need to use what? VC, that equations to calculate SC. Can you write that equation down? Yeah? SC. V is 1 plus, yeah, this is 1 plus NQ divided by NC. We already have that. So 1 plus NQ divided by NC. And then what? B by L? Okay, did you see that B by L? Oh, I want to clarify that. I'll cover that later on. If you see the difference between B dash and L dash and B L, all right? B and L are the actual dimensions. So B dash and L dash are the effective dimensions. Effective means if your load is not in the center, in our problem it is in the center. Thanks God. It's all good. But if it is eccentric loading, then we need to convert the actual dimensions to effective dimension. I'll cover that very next. All right, okay. But for now, load is in the center, so no worries. I don't know what type of engineer will make the foundation here and apply load on the side. Okay, so that's the problem. We will be looking at this, but for now, B dash L dash will be same as B and L. Interesting. All right. So NQ and then what is that formula? So B, we are doing basic, yeah? B by L. B over L equal to 1 plus NQ is what? 10.7 divided by NC is 20.71. Both are dimension same, so 2 over 2. That's the easiest one. How much you got? 1.52?
Yeah.
Okay, good. All right. So now, second one is what we need to calculate is SQ from basic. Okay, look at this symbol there. So SQ is the second equation. SQ for basic is 1 plus B by L 10 phi. 1 plus B by L 10 phi. It should be 1 plus B by L is 2 over 2. Easy for that. 10 phi is 25 degrees. Can you do that for me? $1.466?
Yeah.
All right. So now in S gamma, say factor we are doing, S gamma would be, is this written something there? Yes, basic, right? That one, right? It must be greater than 0.6, right? That's for Hansen, yeah? So we need to look, of course, because this to be the shape of the foundation, it will be more than that. So 1 minus 0.4 V by L. 1 minus 0.4 is 0.6.
Yeah.
Yeah? So 1 minus 0.4, 2 by 2, it should be 0.6. Say factor done. Now we go for the depth factor. All right, depth factor DC. Can we see that there? They didn't write any subscript there, right? Oh, no, they haven't, right? So now we can use for both, right? Like for Hansen as well as VSIC, we use the same if they haven't written the subscript. So now we need to check G by B. How much is B? 0.3? B is 2. How much you got? 0.15? 0.15 is that one, right?
Yeah.
So you need to use, this is K value is D by B. 0.15, you put that into this. You get the DC. DC 1 plus 0.4 K. So DC equal 1 plus 0.4 K. K is 10 inverse or just D by B? Just D by B for our case.
Yeah.
So equal to 1 plus 0.4 times D is 0.3, B is 2. Can you compute that for me? Oh, it becomes very small, 0.1, 2.6, 0.06, 1 point.
1.06.
Yeah, good. 1.06. Done. DC is done. What's the next? DQ? DQ is, where is that? So here you go. So DQ. So K defined above, so we can use the same tool. So, please use your scientific calculator. dq, it must be, I'll write that equation first from there. 1 plus 2 tan phi, 1 plus 2 tan phi, and is this bracket? Yeah, 1 minus sine phi square, 1 minus sine phi square. K value is d by b, which is what? 0.3 over 2, equal to 1 plus 2 tan 25. So 1 minus sine 25 times 0.3 over 2. Best of luck for them to finding this type of equations.
It's 1.046.
You already computed? All right, yeah. 1 point. So now is a dq is 1.046, yeah?
Yeah.
Well, that looks all right, yeah. So now d gamma, is there anything given there or 1?
Just one.
1, right, for any phi. Look at this. These guys are easy guys. Guys, all good. So now, so gamma is 1. So depth factor we already got. So now we need to get load inclination factor.
Can you just display him?
Which one?
Can you just
Oh, this one? All right. Thank you. Yeah, you remind me. All right. That's how I write. Okay. I don't know whether you can read or not. I think depth factors and depth factors. Yeah. So SC, SQ, S gamma, and DC, DQ, D gamma. That's it. All good. So now what's next is load inclination, right? Can I go back to my lecture? Otherwise, I'll be stuck there. Okay, so load inclination factors, right, over there, at the top there. Read here again, right? So Hansen and a basic, right? 4.5 for equivalent basic equation, so you can't use this table now. You need to go to the next table. Do you get it at the top? It says table 4.5c for equivalent basic equations. These are only for Hansen equations. We are doing basic now. You remember? Go to the next. All right. Oh my goodness. Here you go. Oh, there are a lot of things, but yeah, just leave that for now. Just let's do this. Okay. So IC, IQ. So IC. This is not the case for us. Yeah. So only this case. So NQ we already know. We need IQ first to calculate IC. So that's why IQ is given by that. This is horizontal load. That's the vertical load, and that's the area of the foundation. And there's the cohesion at the bottom, right? When the horizontal load, there is a friction there. So we can assume this as a C. I think that is written also in the problem, right? Somewhere we can assume CA equal to C and a quad phi. Everything we know, what we don't know. M? And then M is given here. All right. All right. Yeah, you guys are laughing like me. All right. So M is given because our B and L is same.
Yeah.
We will get only one M. Lucky, little bit lucky, right? At least one less calculation. So we calculate M here, and then substitute M there to calculate IQ. Put IQ there to calculate IC, and then we get I gamma from there. After you get M, so it's all now.
That is M plus 1?
Yeah. First is only M. That's the M plus 1. All right. You know the process, right? Yeah. So what I'll check timing. Yeah. All right. So let's first calculate M. Okay. And then we go back. All right. That would be easier. Yeah. So let's check first M, right? For load inclination, right? Load inclination factor. Load inclination factor. So first let's calculate M first. M would be, based on that, M would be MB, same thing, 2 plus B over L, 2 plus B over L divided by 1 plus B over L, 1 plus B over L. B over L is 1, so 3 over 2, so 1.5. Oh, that's the easy one.
You can calculate DMB.
Which one?
So there is two equations for M equal to MB and M equal to M1.
Yeah, I think not MB, and this is one, not one, L. It's the lengthwise, this is the widthwise. In our case, it's a square footing, so same. If there was a different, we should calculate. Okay, for the rectangular type, we need to calculate both. Yeah, and if it is just we need to calculate all for both sides.
Okay.
You got it, right? So widthwise, and the length 5. Okay, so first calculate m, and you will have these all values, width and the length side. Okay, but usually the critical becomes when it is a smaller part, because bearing, you see, if you spread the load over the wide area, right?
Yeah.
So it will have less effect on the soil. That is small length, right? So usually critical is width, but these guys they suggest to do.
So can I explain the IQ formula, sir? What is the V?
This is the V is the vertical load. Yeah, 600 I think in our case.
Yeah.
Good. And then H is the horizontal load. And this, did you see I? This is only one direction is given with one direction, but sometimes load can be in the longitudinal directions too. So that's the reason why we need to calculate both. Right? But our case, there is no length and no load in the length direction. So it will be easy. Only one value needs to be calculated. All good?
Yeah.
Clearly understood, right? Yeah. So let's start. Calculate m first. M is 1.5 we did?
Yeah.
So now, substitute what we want now. Maybe we can calculate this instead of
IQ.
first IQ we need for IC, right?
Yeah.
Let's calculate IQ. Yeah. We can't do IC now because we need IQ.
Yeah.
Start from IQ?
We need lot of things.
Of course. Of course we do. IQ. I don't believe you did this in your undergraduate. I think so. We are getting complex now, yeah? Of course, Tezagi maybe a little bit more off. That's it, yeah? After this is a little bit. IQ equal to 1 minus. So H, I'll just write H. I'll not write subscript because there is only one direction of loading now, right? Not length and width, but just the width one. H divided by V plus AF. B plus AF, area of foundation, and then there is a CA, which is, I can write just C, the cohesion of the soil, and cot phi. Cot phi to the power 1.5, yeah? Equal to 1 minus H is 200, divided by B is 600, plus area of foundation is what, 2 by 2?
Yes, sir.
And then C, cohesion was what, 25, yeah?
Yeah.
25, and the phi is also cot 25, not 10 here, all right? We use a lot of 10 to the power 1.5. Best of luck for your calculator pressing. And then tell me what you get at the end there. 200, that should be all right. There you go. Okay. So this is the 1 minus 200 divided by that O, yeah? And then if you need to put bracket in the calculator, right? Yeah, 200 divided by bracket, all of them. And then to the power 1.5. I'm not going to press here. How much you got? IQ?
Yeah.
We got slightly different here.
It's all of them.
Power is 1.5. So what? How much you got at the bottom? B plus AFCA cot phi. They got 814.4 here. I don't know whether that is.
814.59.
Oh, that's all right. That's very close enough. Yeah, that's good because cot phi, that little bit there. And so 1 minus 200 divided by that to the power 0.655 they got here. I don't know. Is it
Yes, sir. 0.65.
Is that correct?
Yeah.
All right. Okay.
Always put the power of them.
Yeah, all right. So 0.5. You see, IQ, we got it, right? Yeah. So go back to my computer. Well, IQ we got, yeah? So once we get IQ, it will be straightforward. I think this is the same, yeah? Inside is same, isn't it?
Yeah. Just M plus 1 is different.
Yeah, just power is different. Can you calculate I gamma now? It will be
Yeah.
easy. Whatever you have inside is same, just outside is a little bit different. So I gamma should be, what is inside is 1 minus 200 divided by 600 plus AF, right? 2 times 2. And then C is 25 cot phi. Cot 25, that's inside is same, just power is 2.5. It becomes now, yeah?
Yes, sir.
And 2.5, that's it. So it should be little bit bigger value, yeah?
Yeah.
Yeah, because of the square of the decimal, it should be smaller. Okay.
0.47.
How much?
0.48.
48. Okay, that's fine. 0.4487.
Yeah.
They got here 49 something. That's all right. Enough for that. Yeah. So now IC, we go to the top to get the IC from IQ. There. Yeah. So IQ take away 1 minus IQ, and take away 1. So IC now equal to, so IQ take away 1 minus IQ divided by NQ minus 1, right? So in this case, should be IQ, how much you got IQ before? 0.655, okay, that's all right. 0.655, take away 1 minus IQ is 0.655 divided by NQ. I think we have at the beginning somewhere. NQ is 10.7, yeah? Yeah, 10.7 minus 1. Okay, so now if somebody wants to see what I have written there, there you go. I see. Please compare that. I see should be, I don't know, yeah, 0.62? All right, that makes sense. Done, inclination done, ground inclination none, because it's a horizontal ground. Only thing is base inclination now. All right, okay, let's go to the lecture note to see the base inclination. Base inclination is at the bottom, yeah? We don't need to do this. This all are one. Ground inclination is not there. Just this. That looks, oh, that one, right? Yeah. BC, BQ and the B gamma same. 1 minus n is the slope angle, right? Yeah? Angle, I think that's given in the problem. Can you check what's the angle of the foundation in the problem? Some 11, 10 degree, anything in the problem. Can you find? 10 degree, all right. So that is 10 now, yeah? And the 10 pi is 25, so you can calculate that very easily. And then you can do this also. B is, what is B? B is the ground inclination, right? Yeah? Yeah, so it's 0. So if this is 0, that's BC is 1 already. All right, good. So now, so can I do that now? So BC is 1 already? Yeah. BC is 1 because what? Beta ground inclination is 0. And then I can do BQ and B gamma. B gamma should be equal to 1 minus, is a 10 degree you say, right? 10 times, you can't multiply one radian value with the degree value, all right? So you need to convert that into radian. Because that's the radian value you get, right, after doing 10 pi. So you need to convert it to radian by pi over 180. Pi over 180, yeah, that's correct. So 10 pi over 180 and multiply by 1025. Because you are not supposed to, anything square or any given in the problem? Square, right? Total. Total is square. Can you, I'll show you my document camera, right? Yeah, there you go. Why I did that is this converted into radian now, because we get the radian value out of this. 25 is degree. When you do the 10 of it, it becomes radian. So you cannot multiply degree and radian. You must convert into radian here. So can you complete for me? Yes. Equal to How much? Calculator pricing. Maybe we buy one calculator, yeah? One is easy to, difficult to use. Huh? Have one calculator, you need that. How much you got? They have given 0.84 here. Yeah, just let's try. I want to try myself here. Calculator. It's not that hard equation, right? 1 minus, so 1 take away. It's a 10 degree, right? Can you check there? 10 multiplied by what is pi? And there is a pi. Is that right? Yeah? Divided by 180. And so is it equal? That's done. A multiply is still there. Yeah? And so 25 of 10, I need to do what is trigonometry? So 10 of that. Good. And equal to, I got this value total. And then I need to do square. Yeah, 844. 0.844. Yeah, 843. That's close enough. All good. So now we got everything. I'm not going to plug in those numbers in the equation, so you do that. All right? Okay. So we calculated all right based on what solution we have anyway. So just plugging in total, you get that bearing pressure. Enough. So we use the same process. Everything is same for Hansen equation. Only thing you need to worry about is safe correction factor are dependent on the inclination factor. So that's the given. I will show you that here. Okay. So only for Hansen. Okay. Nothing else. I have written here page number 38. Only for Hansen equation. So you see, safe factor is based on. Look at this load inclination factor there. All right. So this part of load inclination factor there. That's it. Everything else same. So what my suggestion is, calculate the safe factor first. And I go for the inclination factor, and I come back to safe factor. And others you can continue exactly the same. But look at the proper equations, okay? Don't look at different equations and different things. You need to check from the tables. All right, so that's your practice now. So if I open up the tutorial, you should be able to, can I do that for now? So MSc. Where is my USB? This PC. That's mine. Someone else USB is still there. That one. That and tutorial questions. I want to open up. Not this one. Just wait. Where are tutorial? Oh, here. Here you go. Because my mouse is just so difficult. They don't have even mouse pad here. Eh? So it's so difficult to control. It just keeps moving. That one, right? Up there. And then 1, 2 tutorial questions, right? Yeah, solution there. I'll just make it visible soon, by this end of week. So look at this. Just have, maybe they haven't updated and it closed down maybe. Yeah, it does. It does.
We can look up in Moodle.
Yeah, can you? Can you look at the Moodle there?
Numerical mode in the area.
Yeah, that's a week 1 and 2. There is 1 tutorial exercise, right? Yeah. Okay, I'll just go there first. Okay, this is the solution I am opening here, right? Yeah. I solved this. So I want to show you just the question, right? Look at here. This is the first question, right? Tutorial exercise starting. I'm not going to do that. Very easy. C pi gamma. Depth of foundation is none. And then width of foundation is even. It's a square foundation, right? You need to correct safe factors there. And then all is there, so just use what? Terzaghi method to compute. Come on. That's too easy for you, isn't it? Yeah? So that's the reason why I did the most difficult one here. And so all others you can do. If I go to the next question, look at here. Yeah?
10 questions?
Yeah, 10 questions, and there are some extra. I think the total of 10, yeah, correct, I think. Yeah. So look at this second question, right? Again, What equation you need to use? Everything is same. Only thing little bit about designer is we don't know the width. Okay, so answer varies. Okay, it's not whatever be width you assume. But look at this. I assumed here 1.5 meter to 3 meter width. So it gives us the range of bearing pressure, right? 220 to 240. After you use 1.5, you get 220, 3 to 40. So it does not vary that much, isn't it? Right? Pressure remains the same. So no need to make width this very big because it doesn't change that much of the bearing pressure. Yeah, the source pressure. So there are a few little bit thinking type problems, but you can. So I'll open this maybe tomorrow. Okay? Solutions also. So but you need to try.
Yeah.
You need to try. And there are few questions I'll do. For example, there is a one load inclination problem. That's what we did now, right? Here, square footing, not 1.5. Yeah, this one. I'll do that because I haven't covered that much about the eccentricity. Okay, so what I cover is just a correction factor and basic things, but there is a moment, right? If your foundation is like this, you didn't apply the vertical load in the center, then what happens if you do that way? So slab tilts, right? Yeah. So whole of the foundation doesn't become effective, only some part of it. So I'll be looking at Monday a little bit. Now I'll solve a few problems. Now we'll finish almost all foundations. Good. Okay. Thank you guys. Yeah, I'll stop here now. So again, I want to say I have requested the time change. They have responded. They are looking at it. If they change, then we will do Monday, both sessions Monday. So you need to be very ready with everything and almost 4 hours on that day. So then you don't need to travel to here on Thursday. Okay, so that's what we are trying. Okay, thank you. Any questions for me? No? Did you make your group? Assignment 1 group? You need to select here. You can't do by yourself, so you go to the... Can I see anybody selected or no? No? So what you need to do is, okay, just wait sometimes, M's. So I go there, in the middle, you go. They may ask again. Yeah, here you go. So which one? Yeah, that one. So you go there, like for example, assessments, I think, so where is the tiles? Assessment items, yeah, here you go, that one. So if you go there, and this is the group for team 1, you click on that. And then if you want to be one of the, I moved to 4 now because students' numbers are increasing, 4 members in the team. So I try to fix in 1 or 2 groups. So you just select which group you want, and then save my choice. That's it.
Sir, I want to say that I got the 13 question that you had, 13 research topics.
Not only that, you can go anywhere.
Yeah, sir. What should we do about that? We should source for the research paper on the basis of that topics, and how many minimum research paper we need?
No, okay. Out of those topics, or any extra topics that is interesting for you, you choose the topics first. Decide among your group, right? You have a meeting, you decide, okay, I'm interested in that, and you have a topics now. So now you need to find the topics only for the research papers based on that topic. Not all the research papers for all other topics, only that topic. So I'm interested to see around 20 papers, a list of references at the end. But some of them can be just a report, or some of them can be just a thesis or the PhD or master thesis somewhere in American university. They are recently open. All right. And then some of them can be just a simple report. Okay. Around half of them, I want to see the journal papers. Okay. But again, don't read all, and you wouldn't understand. Okay. Even myself, if I read the new publication, I don't have a clue. I don't understand. So what we need to do is just read the abstract, whether that is applicable to your project or not. Read the conclusion at the end of the papers, and then something says about this or not. Just summarize that. If you need some equations you want to compute, just check that. don't read one line by line each papers. That is not now. You will do that when you do your project in very second year. All right, you will be doing project. So what we are trying to do here is we want to make you familiar with how the project is done.
Is there any certain topic to just select all the research papers and all?
Topics here, I have given here.
Yes.
Yeah, I have uploaded here. You can see that. Yeah, go to the assignment 1.
Yes, sir.
And then look at this. These are the format. You need to present that, right? Research, presentation format, PDF, the PowerPoint slide there. This is the template to write a report about your topics. And this is the assignment item. So let's open it first. So many things are not updated in this computer system. There you go. So these are the topics I have given you a little bit, right? This is just for in. You can choose any other topics if you want, right? Look at this. Advanced ground modification techniques, right? You encounter somewhere, right? Very muddy and old clay swirl. You can't put anything, and somebody asks you to design the foundation. What do you need to do? Of course, you need to improve the swirl first.
Yeah.
Okay, so how you can improve? You can do the research on that. It can be chemical stabilization, putting some cement, mixing, those type of things. It can be mechanical by compactions, those type of system. But don't say I want to just remove everything and put something else. Okay, that may not be engineering solution. All right, try it. That's the one. Modern soil reinforcement techniques. Sometimes we put like a geotextile. Have you heard about this? Synthetic geotextiles?
Yeah.
Because you see slope stability, they usually put nowadays, yeah? So you can take one of the topics and then do the research on that. Another can be advanced site investigation techniques. Nowadays, I used to go and then dig a hole and test the soil, that type of thing. Nowadays, they have a lot of like a density of the soil. They just put some sensors. Yeah, and then put lasers, right? And then it will determine your density. How quick they do so many things now. Why not you investigate what the techniques are available now? Okay, you can do critical steps. Oh, this may be a little bit hard, right? And then unsaturated soil mechanics. I was talking that before. You remember? In 2011, I have introduced that. Soil dynamics, right? How the vibration, and there is an earthquake, and how soil behaves. Yeah, and then treatments of bad soil, like mostly in Australia, we call it sodic soil. What they do is when the rain falls, right, they swell a lot. And then road is like a cracking, because the volume goes up. So sodic soil, you can investigate about those type of problem soil. You can design other foundation expansive soil, that's what I just mentioned. Design of machine foundation is a vibration effect, not like a loading. I gave you now problem just right now. We started loading 600 kilometers, right? Yeah. So vibration basin giving, right? You can do the state construction excavations, a lot of new techniques there. 3-dimensional consolidation, not only 2D, but in the third dimension, how the water dissipates from the soil it goes away, right? And then shaft tunnels, conduits, drainage, dewatering, right? Come on. Yeah, you can say any topics up. You can start Googling what are the most interesting topics in soil mechanics and foundation. And then Google will tell you something, but that is not enough. You need to now go to the research papers, learn all papers about that topic. How is it? Now it's good? Yeah, good. Looking good? All right. 20? When I said 20, you were saying, oh, you need at least, yeah, I need at least one page of reference list. Okay, at the end. Not 1 or 2 from Google.
We can create we can create, we can include 10 reference and create increase the size of
Okay, so the report and the presentation templates are provided, just fill in on that. And then I think I have written here any other topic somewhere, right? Yeah? You can choose your topics by yourself based on what interests you, right? It's not fixed. But please don't, 2 teams don't choose the same.
We should have, so we should write discussion section also.
Of course, everything conclusion. I format
I think format there is no discussion.
Discussion means conclusion, discussion you can put there to put all together, right? Results before that. So that's the format you will be using for your project next year too. Okay. That's it. Clear, please choose the team here. All right, yeah. What you need to do is don't say, okay, just discuss among yourself who you want to work with, and then group one I'll select, so everybody selects group one for that, and then group two another one. That's all right. If required, I'll increase the other one. Now it's getting 9, so maybe I need to keep going. Let's see. Thank you. See you on Monday. Yeah. Hopefully at 11. If no, you don't get any information, come at 1 for that week, but they will change. It takes time. Okay. Thank you. Thank you. Bye. How can I shut down the system?